I'll introduce the idea of sustainability in the Industrialized Building System or IBS. IBS uses prefabricated components made in factories, allowing construction to be faster, cleaner, and more efficient than traditional methods. Sustainability is crucial now because the construction sector contributes heavily to carbon emissions. We need building methods that reduce waste and environmental impact. IBS help achieve this by cutting material waste, lowering on-site energy use, and improving resource efficiency. Because of these benefits, adopting IBS is an effective way to reduce the carbon footprint of modern building projects.
For this topic, our group chose Sekolah Kebangsaan Tambe, which is located in Kota Samaran, Sarawak. The renovation of Sekolah Kebangsaan Tambe is one of the part of Sarawak government initiative for the renovation of outdated and purely built school. The aim for this initiative is to give the student a safety and comfortable environment when they have their learning session. Mostly, primary school in Sarawak, particularly in rural areas, face issues related to old building, isolation, and accessibility problem due to the construction and weather. In response for these challenges, the government has chosen to employ IBS, which is Integrated Building System, which is a modern construction technique focused on the use of prefabricated components and materials.
Now I will explain how the Industrialized Building System or IBS help reduce the carbon footprint in construction projects. The first way IBS contributes to carbon reduction is by reducing material waste. In traditional construction, materials are cut and shaped on site, which often leads to a lot of off-cuts and mistakes. IBS components, however, are produced in factories using precise measurements and control processes. This means every piece is made accurately with minimal errors. As a result, much less material is wasted. Fewer resources are consumed and the overall environmental impact is reduced. Secondly, IBS lowers the carbon footprint through reduced on-site energy use. Traditional construction requires many workers, machines, and equipment operating for long hours every day. Cranes, mixers, generators, and more. With IBS, most of the work happens off-site in the factory, so what arrives on site is already prepared. This shortens the construction period and reduces the amount of machinery needed on the ground. Less machinery running means less fuel burn and few greenhouse gases released. The third point is reduce transportation emissions. In conventional construction materials like cement, sand, bricks, and steel need to be delivered to the site repeatedly, sometimes daily. IBS simplifies this by using scheduled deliveries of prefabricated components because the components are made in bulk, transported efficiently, and the number of trips needed is much lower. This cuts fuel consumption and reduces carbon emissions from transportation.
Next is problem. Today, I will explain some key problems related to using the IBS, especially when our goal is to reduce carbon footprint. First, logistics and transportation are a major challenges. IBS components are big and need to be delivered to remote areas, and long travel distance means more fuel usage. This leads to higher carbon emissions, which goes against the idea of building sustainability. Second, there is a lack of skilled workers. Not all workers are trained to install IBS component correctly. When mistakes happen, the teams need to redo the work, which wastes time, energy, and materials. This again increases the overall carbon footprint of the project. So, for the third problem, we face a lack of local IBS suppliers. Many components still need to be imported from far locations. More transportation means more carbon emissions and higher costs. This also slows down the project progress.
For the solution of logistics and transportation, it is to build more local IBS production hubs. the government must build more so that the supply for the IBS material will not be limited to certain areas, and better planning and routes optimization for delivery toward the construction sites. Another solution for the local IBS supplies problem, the government must have initiative to encourage more local manufacturers so that the local manufacturers will supply more IBS materials, and the government also must promote more public-private relationship among the manufacturers. And the solution for shortage of skilled worker is provide continuous training program and certification through CIDB and local institution, and also conduct skill workshop for the IBS materials from the IBS expert.
So, in conclusion, the IBS is a strong solution for reducing carbon footprint in construction. IBS reduces material waste, shortens construction times, and improves efficiency through its prefabricated components. With the support of better logistics, more local manufacturing, and skilled workers, IBS can significantly reduce emissions compared to traditional methods. It is also promotes cleaner and more sustainable construction in both Malaysia and Sarawak. Overall, IBS is a practical step forward in achieving greener development for our future. That's all from us. Thank you.